So, good morning to all of you. Welcome to the lecture series of integrated circuit, that is KEC 501. In this class, I will discuss about the CMOS logic gate. We will discuss the basic structure and the CMOS realization using the inverter. This is the topic of unit 4th, where we will discuss the digital integrated circuits. So, let us start. These are the content of this lecture. First, we will discuss the CMOS overview, then we will discuss CMOS inverter, then CMOS logic gate. So, CMOS is basically a complementary MOS transistor. When we talk about the digital IC, then there are so many technology by which we can implement integrated circuit in the field of digital. So, these technologies are namely NMOS, PMOS, PTL, that is pass transistor logic, some technology based on BJT. So, BJT is another technology by which we can implement digital IC. Another is TTL, transistor logic, and ECL, emitter coupled logic. And there are other technology by which we can implement digital IC. They may be categorized in non-conventional category like FGMOS technology, CNFET technology, and many more. So, out of these technologies, CMOS technology is most preferable technique. Later in this lecture, we will discuss why CMOS is better than all these technologies. So, here in this lecture, my focus will be on CMOS only, but we can implement any logic circuit, any digital circuit using NMOS, using PMOS, or using PTL, BJT, or any of these technique. So, let us discuss what is CMOS. Basically, CMOS is complementary metal oxide semiconductor, where NMOS and PMOS transistors are used and they are connected in complementary fashion. So, that's why it is known as complementary MOS transistor. This technology is best suited for the realization of digital system because it is having very small size, means the size of CMOS is very less as compared to NMOS, PMOS, and other technology. It is very easy to fabricate, having low power operation. It is having relatively simpler manufacturing, high impedance as compared to other technology that allow to use this technology for the storage devices. So, in digital, if I classify the digital domain, so there are two main category. One is combinational logic circuit, that another one is the sequential logic circuit. So, this CMOS technology is best suited for the sequential circuits where we can implement storing devices like flip-flops, registers, etc. So, because of these features, in case of CMOS, we can achieve high level of integration. That is why CMOS technology is the most preferred technique for the digital IC. Here in this diagram, you can see that the basic structure of CMOS, which is implemented on P type of substrate. So, this region is known as NMOS transistor, because here you can see that on P type substrate there is N type of channel by which the current can flow. Similarly, in this region N well is created to fabricate the P type device. So, here this is N type device, here this is P type device. So, the overall structure comprises of P type device and N type device. So, this is how you can fabricate CMOS. And the advantage of this circuit is low static power consumption. So let's discuss. Suppose we are using NMOS technology. So this is the circuit for NMOS. Here we have to use some resistor to connect it to the output terminal. This is VDD. Let's say this is the input terminal. So you can see that when input is 1, this transistor is on, and if transistor is on, in that case this can be replaced by a closed switch, and here you can see that there is a path from supply to ground, and due to this direct path between supply to ground, there is static power dissipation. Static power dissipation. So in case of NMOS technology, along with this static power dissipation, at the time of switching there is dynamic power dissipation. So here if I calculate the total power consumption by this technology, so there are two factors. One is power dissipation due to static arrangement when there is no switching, and at the time of switching there is another power consumption or another factor, that is dynamic power consumption. So here in this technique the power dissipation is more, but when we talk about the CMOS technology, so I can replace this NMOS with a CMOS. So in that case we can see that the power dissipation is less as compared to NMOS technique. So let's say, just see the schematic of CMOS. So it is a combination of PMOS and NMOS. This is P type of device and this is N type of device. When input is applied at the gate of these PMOS and NMOS, then you can see that when one is connected over here, then due to the high input this NMOS will be on, and that can be replaced by this short circuit, whereas this PMOS can be replaced by open circuit, because for high logic PMOS will be off. So in that case you can see that there is a output which will be due to this NMOS transistor, and this V output will equals to 0. But you can observe this fact, there is no direct connection between VDD and ground. Now VDD is connected with this PMOS and which is operating as an open switch, and this NMOS can be replaced by a small resistor. So now you can see that there is no direct path exists between VDD and ground. You can see that. So that's why if I calculate the total power consumption of this CMOS technology, then only dynamic power dissipation will be there. There is no static power dissipation in CMOS technology. So that's why the power consumption is very low in case of CMOS when we compare it with the NMOS, PMOS or any other technique. So we will use CMOS technology. Later in the lecture we will discuss the noise immunity is very high in case of CMOS if we compare it with the other techniques. So now you can see that this is the circuit of the CMOS inverter. In this circuit you can see that it is consisting of two complementary MOSFET, PMOS and NMOS. The input is applied at the gate terminal, and the gate of both the transistors are connected to each other. The NMOS transistor has an input from VSS, that means the output is whenever this transistor is on, the output is equals to VSS, and whenever the input is 0, in that case PMOS is connected with the output and this output is equals to VDD. So this is how the CMOS itself behave as an inverter. That's why it is written as CMOS inverter. So the device CMOS itself behaves as an inverter. So you can see that the operation of the inverter from this slide. Now, there are some points which are very important. A high voltage is considered to be logic high, and that is equivalent to 1, and low voltage correspond to the logic low, and that is equivalent to 0. So, in digital there are only two logic labels, logic 1 and logic 0, and this 0 voltage is equivalent to 0 input and VDD is equivalent to high input, and that is equals to 1. As we have discussed in the previous slide, that for high input the output will be due to the NMOS, and the output terminal is connected to ground. So, this output is equals to 0 volt, whereas when 0 input is applied, then output is output is due to the PMOS circuit or PMOS transistor, and then when PMOS is on, the output terminal is connected to supply. So, the output is equals to VDD, and this VDD is considered as logic high, and this 0 volt is considered, or ground is considered as logic 0. So, this is how we can implement a inverter which is a NOT gate. If I say the if I draw the logic diagram of inverter, so this is something like this. So, this is how we can implement this NOT gate using CMOS inverter. So, CMOS inverter is equivalent to the NOT gate. So, here we can understand like we have implemented the NOT gate using CMOS, we can implement any gate or any sequential circuit using the CMOS inverter. So, now we will discuss the CMOS logic circuits. So, if I talk about the CMOS logic circuit basic structure, the CMOS logic is basically designed using two networks. One is pull up network, second one is the pull down network. This pull up network is made up of only the PMOS transistors. So, this is made up of PMOS only. In pull up network, only PMOS transistors will be used, whereas in case of pull down network, only NMOS transistors will be used. If we calculate the output, so this PDN network will gives you the output when NMOS transistors are on. When NMOS transistors will be on, in that case this output node is connected to ground, and that will produce the logic low at the output node. So, I can say the PDN is responsible for the producing 0 output, because in case of digital there are only two logic. So, we can understand how we can generate the logic low and logic high. So, PDN is responsible for producing logic low, whereas whenever this PMOS network, that is PUN, whenever this PUN is on, in that case this output node is connected to VDD, and whenever this output is connected to VDD, that means this output is equivalent to logic high, that is 1. So, this is how we can generate logic 0 or logic 1 as per our requirement, as per the given problem, using this CMOS inverter. One thing is to be noted, that the PDN and PUN are the dual networks, because they are complementary to each other. So, if the NMOS transistors are connected in PDN, so the dual network can be implemented at the PUN network using the PMOS transistors. So, here with the help of this structure, this is the basic structure for the CMOS logic gate. Any combinational and sequential logic circuit we can implement using this basic structure of CMOS, and this is known as the CMOS technology, and this is this can be used to implement the different digital ICs like NAND gate, NOR gate, flip-flop, register. Different digital ICs can be designed using this CMOS technology by using this structure only. So, now let us say how we can implement PDN and PUN. So, this is our objective, to implement PDN and PUN. if I compare this circuit with the previous one, this is, so here I can write this is the transistor for PUN and this is the transistor for PDN. So here you can see that in PDN only one transistor is used because there is only one input, whereas in case of PUN only one PMOS is used because there is only one input. Suppose I want to realize a NAND gate or NOR gate, in that case we are having two inputs. So for two inputs we have to see how we can implement this PDN and PUN. So there are simple rules to implement these type of gates using this CMOS logic structure. So whenever we are having any expression, let's say we are talking about NAND and NOR gate. So suppose just write the expression for NAND gate. So for two input NAND gate, this is the expression F equals to A dot B whole bar. Similarly for NOR gate, the expression will be A plus B whole bar. So if I want to implement this equation first, this is the Boolean expression and the objective is to implement this gate using the CMOS technology. So for that there are just two rules, we have to follow that and we can implement any circuit, any logic function or Boolean expression using the CMOS logic gate. So rules are like this: to implement dot operator or for AND gate or for AND operation in PDN, NMOS will be connected in series. NMOS will be connected in series. Whereas to implement the OR function, that is OR function, the NMOS will be connected in parallel. Like for first expression, let's say this is equation 1. So for this equation 1, now we can implement PDN and then we will see how we can implement PUN. So let's have a look. As I have already told you, for the AND operation, the transistors should be connected in series, and for the OR operation, transistors should be connected in parallel. So I am talking about this equation 1. So here in between A and B there is a dot operator, that means I have to use two transistors, and as per the rule these two transistors must be connected in series. So this is A and this is B, and you know that the PDN is connected with the ground. So this network is connected with ground and this is the output node, this node. So this is the structure for PDN. Very simple, just using this thumb rule for AND operator, NMOS must be connected in series. Now I have already told you the PUN is the dual of PDN. So we can implement PUN network just by looking the PDN. In PDN, if transistors are connected in series, so in PUN that must be connected in parallel fashion. So I have connected two transistors in parallel fashion, but I know that PUN consisting of PMOS transistors. So this is the symbol for PMOS. So in PUN, PMOS transistors are used and PUN is connected with VDD. So here the supply is connected. The input will be, this terminal will be A and this terminal is considered as B. Now you can see that in this circuit, which is a circuit or CMOS implementation of NAND gate, there are two PMOS transistors and two NMOS transistors, and in if I see in detail, then there are two inverters, one inverter which is made up with this transistor 1 and 3, and second inverter which is made up of transistor 2 and 4. If I just flip the direction of this second NMOS, then easily I can connect it with the input like this. This is the A and this connected with B. So this is how we can implement NAND gate using CMOS logic structure. You can see another example for NOR gate. For NOR gate, this PDN comprises of two NMOS transistor in PDN, because for NOR gate there is OR operation between A and V. So this OR operation can be performed by connecting QA and QB in parallel fashion. I can implement the dual of this PDN to design the PUN for the NOR gate. So like for this circuit, the PUN will be like this, and this must be connected with the VDD. The input is A and B. Both the transistor can be written as Q, P, B, Q, P, A. And from here, we can get A plus B whole bar. So this is how we can implement any Boolean function. So the sum rule is simple. For AND operation, we have to use series connection in PDN, and for the OR operation, parallel connection in the PDN, and PUN we can implement just by looking in the PDN circuit. So here this is just the implementation of PUN we have already discussed. Just by combining this PDN and PUN, we can see that the logic or circuit diagram or CMOS implementation of NAND gate, 2-input NAND gate, and there is the circuit implementation of 2-input NOR gate. If I want to increase the number of inputs, then we can add more transistor in the PDN and corresponding transistor in the corresponding PMOS transistor in the PUN. So for the 3-input, there is another transistor in the PDN, and for the same, there must be a parallel transistor which is connected for the PUN for NAND gate, and similarly we can do for the NOR gate. So this is all about the CMOS implementation of any logic gate using the CMOS technology. Like we can take another example. Suppose function f equals to AB plus C whole bar. So this is a Boolean expression, or this is the complex function where one AND gate is used and another OR gate is also used. So easily we can implement this function just by designing the PDN first. So A and B we can implement like this, A and B, and this is the OR operation. So to implement this OR operation, the transistor C must be connected in parallel, and this is the PDN. So this must be connected to ground. To implement PUN, a dual network is to be formed. So to implement this dual network, A and B must be connected in parallel, and these are the PMOS transistors, whereas this C transistor must be connected in series. So this PMOS is connected like this, and from here you can implement AB plus C whole bar. So this is how you can implement any Boolean expression. I hope you have understood the concept how we can implement any Boolean function using the concept of CMOS logic gate. So this is all from my side. Thank you so much.